everyone, and thank you for joining. My name is Nastaran Ghadar, and currently I'm an engineering manager working on ads at Twitter. I have extensive background in machine learning and computer vision, and throughout my career, I have worked on different sectors of these applications. Recently, I've been focusing on building machine learning algorithms for ads prediction. Today, I'll be talking about feature engineering and data pipelines in social media, and I hope you enjoy this talk. Before going into details of how we use data in our machine learning pipelines, I wanted to give you an agenda for today's talk. I'll start by giving an overview of why we care about data and how data can be used in machine learning algorithms. Then I'll go into data pipeline cycle where we discuss the ingestion of data until it's used in a machine learning algorithm. After talking about data, we'll talk about different feature types and then offline feature analysis versus online feature analysis. And finally, using these features in machine learning models. And I'll conclude this talk by giving an overview of what we talked about and some of the challenges that we're dealing with. So, if we want to answer a few questions, we understand the importance of data and how it can be used in our machine learning models. So, what is data? How is it different from feature? How does data can help us predict? What should we try to predict? And what are we trying to optimize? I always say I look at data as fuel, as like a fuel for cars. So even if you have the most advanced cars, um, if there's no fuel or electricity where it can give your car the basically the food that it needs, the car will not drive. It's similar in machine learning algorithms. As much complex as a system you have, if you don't have the correct amount of data and the related data, it will not work. So gathering data and having the right amount of data is quite important in a machine learning algorithm. Once you have the data, you can extract features from the data. And once you have those features, you can use those features in your machine learning algorithms and optimize it in a way that it gives you the best response. So we'll go deeper into each section in the future slides. So as I said, we'll be discussing the data pipeline cycle. We start by exploring data and forming a hypothesis. What I mean by that is if you assume that, for example, you have a set of data, like you have a set of users where they have different characteristics like their age, their location, what they're interested in, you can form a hypothesis that based on these different user types and categories, what they would be interested in to know more about. Once we have formed our hypothesis, we'll do a modeling. In the modeling stage, we'll do offline iterations and testing. Since social media apps are online and users interact them within real time, it's quite important to have like offline iterations and do testing before going online. So we make sure that whatever our hypothesis is actually makes sense. Then we extract features and feed these features in a way that our models can digest them. So in the feature engineering step, it's quite important to tackle a few problems like latency and how these features fit into online modeling. The next step is to productionize and make sure that our data is reliable. So data reliability and productionizing is quite important in any production model. We need to make sure that whatever our hypothesis was and we validated it with offline modeling, it actually projects into online. Next step is human evaluation or A/B testing. So basically, let's assume that we had a model. Now we think that there will be a new feature that will be helpful to our model. We do an A/B testing where we test the model with and without the feature. And eventually, once we have this set up, then we will connect the modeling to our A/B testing because we need to make sure that our modeling is also validated. And our feature engineering and our modeling are also part of the hypothesis. So eventually, we serve this model online using all these components in a data pipeline. So I talked about feature engineering in the previous slide. What I mean by feature engineering is basically the process of using domain knowledge of data to create features that make machine learning algorithms work. So it's important in terms of how we interpret the data when we want to use them in machine learning algorithms. Features are basically representations of the data that we have in our machine learning algorithms. So, to give you a better idea of what I mean by features and some of the features that we currently use in our social media apps, um, I can give you different categories of features. We have different feature groups like user, ad, context, and interaction. When I talk about user, as I mentioned, there are simple things that you can get from some data that you can get from the user and convert those into features that are meaningful and you can actually use in your machine learning models. Some of these features are like age, gender, interest, location, targeting criteria, past engaged advertisers, installed apps, or user client. So, for example, if a user installed an app before, that could be an indication of what they're interested in, or if they see an advertisement, what would they likely be basically installing next, or with what advertisers in the past they have engaged before. So these are specific information about user that we can convert into features and use in our machine learning models. For the ad feature groups, some of the things are IDs. So each advertiser has its own ID where we can specify which advertiser we're talking about. Targeting criteria, for example, there are targeted keywords that they are interested in. Ad domains and categories. Number of followers, for example, how big is this advertiser? How many people actually follow this advertiser? High level content information, whether this ad has media, text, what is the length of the text, and different information that you can get about the content of that ad. And then the app details like categories, rating of this app. For example, if this advertiser is about an app, how many ratings it has, and what is the publisher rating, and what is the category of this app. And counting features. How many people have actually, for example, installed this app? How many clicked on this page? So these are all useful information that we can convert into features in the ad category group. Next one is context. Examples of context features are like, for example, where this ad is displayed. So the display location, the client ID and version, when it was requested, the request time, whether autoplay is enabled. Like, for example, some users will not specifically click on an ad, it just like goes on autoplay. Network status, career and connection type. So how the profile topics are. For profile tweets represent the current profile page. What is the search query? So these are all information about the context of what the user is looking for and how an ad could be a good fit for that user. So these are like our all around context features. And finally, interaction group where user and ad interact with each other. So we are looking for features that show the interaction between the user and ad. So like how they engage with an ad. For example, if the ad is a video, are they watching the video? How long does it take for the user to pass and move to the next ad? User session record, short-term user ad, engagement, like fatigue. Sometimes like a user sees multiple ads and then is tired, don't want to look at more ads, just like scrolls down or up and do not look at other ads. And what are the match targeting criteria? Like if specifically a user is looking for something, how match it is, how much matched it is with like the user target, like with the ad targeting criteria. So these are all different type of features that we can extract from data. So to recap, so far we have gathered data from users or advertisers, and from these data we extracted meaningful features where we can use them in our machine learning models. So we talked about different stages where we ingest data, and finally we want to use this data in our machine learning models. So as we talked about, data retrieval is the first step where we gather information about different users and advertisers. Next, we need to identify features, and it's important to know that not every feature is suitable for every machine learning model. We cannot just throw any sort of representation of this data and assume that this will work in our machine learning model. It's important to gather meaningful representations from this data and use those as features in our machine learning models. Next step is offline simulation. As we said, in social media apps, users interact with the social media app in real time, and it's online. So it's important to make sure that we have a good hypothesis and we make sure that we have validated that in an offline setting. So in the offline simulation part, we prepare the data and then do simulation in offline setting to make sure that the model that we want to put online actually works. And then next step will be online serving. So we want to launch these features into an online serving pipeline where they can be digested as they are basically built. And finally, we want to apply these features in our machine learning models and use them for predicting different behaviors from the users. So, as I said, after the data gathering and extracting features, we need to have like an offline setting where we can test our hypothesis. So as a first step, we prepare offline data set containing information to calculate the features. And next step, we extract these features. And finally, we calculate the features and use them into simulation for offline results. And then let's say that we have gathered these features offline. Is that going to be the same from online feature extraction? Do we need to do any further steps for us to be able to do online feature extraction? And the answer is yes. So assume that we have gathered a few months of data from different users, and we have assumed that time stopped. We are not going further in time, and we're not real time. But the reality is, once you have stopped gathering this data, it means that this is like based on past information. You're not adding any new information to your data set, and the behavior of users change daily and like in seconds. So we need to make sure that our online data set contains the information that we can gather at real time and put back into our data set. Once we have that preparation for our online data set gathering, we can retrieve that information into online server where we can extract features real time and feed them back into our machine learning models. Basically, in the feature extraction stage, we need to calculate the features and put them into a place where they are available for prediction requests. So it's quite important that we understand that when we are serving features online, there are a few bottlenecks that we need to accomplish. For example, latency is an issue when we are serving features online, but it's not an issue when we are offline because we have all the time in the world to calculate the features and put them in the models. But when we are online, we want to make sure that we can extract these features in a timely manner and feed them into our modeling pipeline. So, how do we apply these features into prediction models? Let's say we have extracted these features. The next step is to do feature transform, then feature crossing, and eventually this will go into the ML model layer. So, we mentioned four steps into like from getting the features into serving them into ML model layer. So if we want to digest and dissect these steps, the first step is that the features are fed into a prediction model. A list of transforms are applied to these features. These transforms can be added, can add features, remove unwanted ones, and adjust chosen values. Basically, we need to make sure that our features are set in a way that are structured, are useful, and if there are any unuseful information, we can avoid them and eliminate them from our features. Next, features are crossed to allow interaction between them. So we need to make sure that we have this availability for features to interact. And basically, if there's any cross correlation between the features, if there's any dependency, we are able to capture that in the feature crossing stage. Finally, ML model is applied to achieve prediction score. So when we talk about feature transform, we mentioned that we want to make sure that these features are in a way that can be digested by the ML model. And we want to make sure that we have eliminated unuseful features or made sure that these features are healthy. But what are the steps that we can use in a feature transform layer? So the first step is deep learning. We can apply a neural network to existing features and extract the values in some layers as new features. So we can basically use neural networks in a way that we can optimize these features that we have and add them as new features. Then the second step is optimization. We need to make sure that we have an optimizer where by using existing features and generating a multi-hot encoding, we have new features that um, basically are more optimized, more useful in our setting, and can be applied in our models. Next step is encoding. So we need to bucketize each continuous feature into one hot binary encoding as new features. Sometimes it's hard to work on basically continuous features. So one way of dealing with that is using encoders and making them binary or like discretize them into a way that it's easier to use and digest as features. Then the next step is feature selector. Basically, it keeps only the selected features and remove others. A typical use case is to remove all continuous features if we are to use only binary features in the model. Using like binary type features helps us with latency a lot, and also it's easier to deal with rather than working with continuous features that are usually huge in size and harder to deal with. So there are other things that you can do in the feature transform stage where like you can do normalization, discretization, crossing, and any other ideas that you may have where you think that it will transform the features in a way that are more useful for our machine learning serving. So it's quite important to make sure once we have extracted features and have done the feature transform stage, features are in stage that can be used online and easily digested by our machine learning model. So is that all the time the case? Is that the scenario that we do an offline data gathering, extract features, and then do online feature extraction and then feed them into our models? So there are times that this may not work. And the online learning is a common challenge where we can think about two versions of training. One is batch training, which is basically what we talked about. There will be a training phase and then there will be a serving phase. In the training phase, we have the data stream, we gather this data, we write it into our model, and in the serving phase, we use the data stream in the training phase and basically read that and use that for our prediction. But what about real-time training? Could that be useful? And if so, is that harder? The answer is yes. If we want to do real-time training, it is definitely harder because we are doing everything at the same time. We have the data stream and we are reading and writing that to the model. And then um, in the serving time is also reading and writing the same data stream into our model in real time. And then we want to use that model to do prediction real time. So there's quite a difference when we do batch training versus real-time training. And it's quite important to understand that how much harder it is to do real-time training. But there are applications that if we do real-time training, the results are much more superior than if we do batch training. And the reason is that the behavior of users change all the time. And if we get to keep up with what the users are doing in real time, then it means that our predictions are more accurate and more closer to what the user actually wanted to do. So this is like a common challenge in online learning. And there are a lot of times that we sacrifice the accuracy of our prediction models because we cannot do online learning and real-time training, because it takes a lot of effort, a lot of hardware and software optimization to be able to do things in real time. So to give you a conclusion, we talked about the core of any ML pipeline. And it's important to know that however complex your machine learning model is, without good data, without enough data, it can't do anything. So one of the major drawbacks in developing machine learning models is to make sure that you have the right amount of data, and not just the right amount, but also the data that can actually tell you things. So, for example, if you, going back to the car example, if you put in an electric car fuel, it's not going to work. So it's important to know that your data is useful for that specific car that you have. So it's important to know that your machine learning model is using the right data and the right amount of data. So once we have enough data, we can extract meaningful features from this data. So it's important to know that just giving raw data to a model will not work. You have to think about what representations and what information you can gather from this data and how you can convert that into features that can be used for your machine learning model. The next stage is to do a simulation offline. Basically, make sure that your hypothesis is valid and you can train a machine learning model using these features and get good gains. That could be an indication if you serve this model online, hopefully you will get similar results. It's not always the case, but without that indication, basically you are just throwing in the dark. The next step is that once we have the confidence that the features are useful, we can bring these features online. And as we talked about, in online serving has its own challenges, its own criteria, and we need to make sure that when we are serving models online, we have done the right transform and we have got rid of the unuseful information and have the what we're looking for. And then finally, we need to use these features in online setting. Once we have that in online setting, there might be challenges with latency. There might be challenges with the size of the model. We might need to convert some like continuous features into binary features and use different techniques to make sure that the serving online makes sense. Once we have that, we can use these features into an online ML model and use them for prediction or other means that we are building our machine learning model for. I hope you enjoyed this conversation today, and thank you.